Hello Year 8. Hi. On this video, we'll be finding the square root and the cubic root using prime factorization. Okay? And we'll do prime factorization by a factored tree. We did factored trees before in previous chunks, but again I'll be reviewing that. Okay, so to make a factored tree or prime factorization, we need to know what primes are, or prime numbers. Okay, so let's have a quick review about that. So, prime numbers. Prime numbers, like numbers 2, 3, 5, 7, 11, 13, and so on, okay, they have two factors only. Their factors are themselves and one only. Okay, I cannot find two things to multiply to get 5, two whole numbers, or two whole numbers to multiply to get 13. That's not possible. You cannot find two whole numbers to multiply to get the number 13. That makes it a prime. Okay, and then I'm saying that 9 is not a prime because it's 3 times 3, 15 not a prime because 3 times 5, but 7 is a prime because I can only do 7 times 1. Okay, so these are prime numbers. You need to know this well. Okay, so to make a factored tree, let's start by having a factored tree for the number 18. Okay, for 18 I think of two numbers to multiply to get 18. Alright, so I can think of 6 times 3. If it's a prime number, I put it in a circle. Like that, I'm done. If it's not, like the 6, I continue. So 6 can be written as 2 times 3, which are two prime numbers. So like this, I'm done. 2 and 3 are prime numbers. Great. So 18 can be written as 2 times 3 times 3. Finished. Alright, let's try something harder. If I have 36, okay, and 36 can be written in lots of different ways. Let's do it as 9 times 4. Okay, and 9 times 4, number 9 can be written as 3 times 3, because it's not a prime yet. Now these are primes. And 4 can be written as 2 times 2. Again, two prime numbers. So, now let's relate this to getting the square root of 36. Okay, the square root of 36 is, so 36 itself is 3 times 3 times 2 times 2. If I combine these two, in the square root I'll only write it once. And if I combine these two as a square root, I'll only write it once. 3 times 2, 6. And the square root of 36 is actually 6. Okay, so this can help me a lot. If I can write a number and write it as a prime factorization only in primes, I combine each two. So when I combine these two, I only get one of them, and when I combine these two, I only get one of them. Okay, let's try something similar. If I want to get, for example, the square root of the number 144, sorry. And I know that 144 can be written again as 12 times 12. Okay, or another person can try 144 and can divide it by 2. Okay, and dividing it by 2, how many 2's will go into 14? That's 7. And that would be 72. You must know long division, of course. So another person can do this as 144 2 times 72, and then 72 can be written as 2 times something, 2 times 36, and 36 I actually know already that it is 3 times 3 times 2 times 2. Okay, let's actually do that. 3 times 3 times 2 times 2. Okay, so 144 can be written as all of these prime numbers. 2, 2, 3, 3, 2, 2. 2, 2, 3, 3, 2, 2. And then now I combine. If I want to do the square root, I combine each two. I write them only once. each 2 I write them only once, and each 2 I write them only once. 2 times 3 is 6, 6 times 2 is 12, and yes, the square root of 144 is exactly 12. Okay, I'll only say a small thing about the cubic root. So if I want to get the cubic root of a number, I'll combine 3's together. So if I have 125, and I know that 125 can be written as 5 times 5 times 5, I combine 3 together, and they make me only 5. One of them. So each 3 will be combined, and I write them as 1. Unlike the square root, each 2 I combine them, and they make me only one number. So that's how I can find square root and cubic root using prime factorization.